Today we will learn about method of false position. A method of false position is also known as Regula Falsi method or the method of chords. Here also our main objective is to find out the root for the function f of x when f of x is equal to 0. So here again I'm going to draw a diagram, and from the diagram we will see how to find out the root of a particular equation or a function by using Regula Falsi method. Now, Regula Falsi method is closely associated with the bisection method. I hope you remember how we did the bisection method, right? So, in bisection method, how did we found out the root of the particular function f of x? Yes, the first step was nothing, but we found out what a and b, two values a and b, such that f of a and f of b were of opposite sides, right? That was our first step. So again we are going to repeat that first step over here. So let's have a look. Like suppose these are the two values a and b, and what was our condition? Yes, f of a and f of b are of negative sign. So let's mark f of a over here and let f of b over here. Okay, since f of b is a negative value, I have marked over here, and f of a is a positive value, I have marked above the x-axis. Okay, this is just an assumption. As I said in bisection method, you can take this value as b instead of a. That is up to you. For my convenience, I have taken this as 2 points a and b. And I am assuming that there is a function f of x which passes through between a and b. Okay, now since it's a continuous function, it's cutting over here somewhere at the x-axis. I'm not sure where it is cutting at, but somewhere over here. I don't know the exact point, but the only thing I know is what, that in this point y is equal to 0. We'll come to that later. Now we will have a close look at what happens over here. If I draw a line over here, and if I connect it with the f of b, if I extend this line, then I get a point over here. Okay, I'm going to mark this point as b, and what is b? Small b and f of b. So this is a point, and here also I'm going to just flow through lines, and here I'm getting a point a, and what is a? It is a and f of a comma f of a. So I got 2 points a and b, and this is nothing but f of x, and it is a continuous function. Now here, this point which is cutting at the x-axis, I'm going to mark it as C. Okay, now I will write the coordinates a bit later. So this is the basic thing that we have done over here in the diagram that I have explained. Now I have to find out what is our objective. We have to find the root of what? F of x. In order to find the root of f of x, I'm going to seek the help of a chord. A chord is nothing but a line that is joining a and b. So AB is the chord. So that's how this method got the name method of chords. So by finding the equation of the chord with some other calculations, we will find out the root of the function f of x. So with the help of the chord a and b, we are going to find out the root of the function f of x. I hope you have all studied the slope of a line, right? So here a and b, what will be the slope? What is the formula for that? Yes, we'll write down the formula. It's nothing but y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. Now this is the formula. Okay, now what we are going to do, this is a general formula. Now we are going to substitute the values which are given in this graph or this diagram to this equation. Let's give this equation a number. Let this be equation number 1. And for the time being, we are going to mark, so for substituting these values in equation number 1, we must be aware of what is y1, x1, y2 and x2, right? So here let a be x1, f of a be y1, and here b be x2 and f of b be y2. So I have given the what values or the numerics over here. Now you can easily substitute all these values in the first equation, and let's have a look at what we get when we substitute these values in the first equation. So as I said earlier, the point A has a and f of a. Now I'm going to substitute a and f of a in this first equation. So for a, I have given the value x1, f of a y1, then for b x2 and f of b as y2. And there was another point called C, which was cutting the x-axis. I hope you remember that, if you remember the diagram. And C is nothing but the coordinates are small c and 0, where 0 is nothing but it cuts a point at the x-axis where y is equal to 0. We'll come to that later. So we'll substitute first the values of a and b in the first equation, and let's have a look. So here y minus y1, instead of y1 you can write f of a, the whole divided by x minus, instead of x1 you can write what, a is equal to y2. Instead of y2 you can write f of b minus y1. y1 is again what, f of a, the whole divided by x2. x2 is nothing but b minus x1 is nothing but a. So this is what we get over here. So here again, what is y and what is x? So these are the two things that is left behind. And from the C point, from the point C, you will get what is y. Y is nothing but it is 0. So y is 0. So substituting that over here, 0 minus f of a divided by x minus a. Now what is x here? So in the point C, x is nothing but small letter c. So that is written over here, c minus a, which is equal to f of b minus f of a divided by b minus a. Now as I said earlier, our objective is to find out the root of an approximate root for the function f of x. Now the approximate root of the function f of x, where does that lie? It lies somewhere between a and b, such that f of a and b and f of a are negative values, and there was one more condition. Yes, f of x should be equal to 0. When f of x is equal to 0, that means y is equal to 0. The root is somewhere over here. So that means it is somewhat approximate to c. So we have to find out c. So from this equation, that is let this be equation number 2. From equation number 2, let's find out what c is. Okay, which implies when you cross multiply this equation, just find out what is c by cross multiplying this equation. Okay, here you can see that I have cross multiplied and I have found out that, see, when I cross multiply I get minus f of a into b minus a is equal to c minus a into f of b minus f of a. Okay, now I am going to open the brackets. When I open the bracket I get minus f of a into b plus a into f of a is equal to c into f of b minus c into f of a minus a into f of b plus a into f of a. Now I have underlined these two terms, that is a into f of a on the right hand side and then on the left hand side. So these both will get cancelled. Okay, then finally what we get is on the left hand side we get what? Minus b f of a is equal to, here c is a common term, so I take c outside and I get f of b minus f of a minus a into, sorry, I have to put a bracket, close bracket over here. So so as I said earlier, I take the c outside and I get f of b minus f of a minus a into f of b. Now from here you get c easily. What is c? C is equal to a into f of b minus b into f of a, the whole divided by f of b minus f of a. So this is the way to find out an approximate root for the function f of x using the Regula Falsi method. But the method is not over yet. You have find out only the approximate root. Like what we have done in the bisection method, we have an iterative process over here too. But it is somewhat easier. It is not somewhat easier, it is way much better than the bisection method. And that you will understand in a problem. So as I said, we have found only c. Now we have to find out f of c. So you have to find out what is f of c. Now that you have found out f of c, you will have to compare f of a, f of c and f of b. Now here comes two cases. Now case one is when if f of a and f of c are of opposite signs. If they are of opposite signs, then you will have to replace b with c and f of b with f of c in the formula which is given over here, where we found out what c is. Okay, here you will have to replace what? Replace b with c and f of b with f of c. But there won't be any change in what? A and f of a. The values of a and f of a remains the same. When you find out the next root, the next approximate root, that is, I have named it as d. Now d is equal to what? I have replaced, as we have said before, I have replaced and I have got what? A into f of c minus c into f of a, the whole divided by f of c minus f of a. Now the second case is when if f of b and f of c are of opposite signs. Okay, now here there won't be any change in b and f of b, but the person who is going to change is none other than a. So here we'll have to replace a with c and f of a with f of c. Now hence you will get another root, that is, here again I'm going to name it as d, either this or that you will get. So again I'm going to give it the name d itself, and d is equal to what? C into f of b minus b into f of c, the whole divided by f of b minus f of c. So in this way you will find out the other approximate roots till you get f of x is equal to 0, till it is the root. So again you will do this procedure again and again, and till you get the required root. Now let's have a look at the working procedure of the Regula Falsi method or the false position method. Now the working procedure is nothing but the first step is to find out a and b such that f of a and f of b are of opposite sides, and after that you have to find out, the second step is that you have to find out c using the formula that we have given before. And after c, what will you find out? Yes, you will find out f of c, and then yes, you will compare f of c with f of a and f of b. Now if f of c and f of a are of opposite signs, then what is the thing that you are going to do with the formula? Yes, you will change b, you will replace b and f of b with c and f of c. There won't be any change in the case of a. And then if f of c and f of b are of opposite signs, then what will you do? You will replace a and f of b with c and f of a, and there won't be any change in f of b. Then that's how you will find out the next approximate root, which is d, and then you will move on like that till you get the required root. So this is the working procedure of regular falsing method. We will do a problem, and I hope you will understand the problem well after following this method, and I hope you have understood the class right now.